Good day. Welcome to this webinar using the HIKMICRO thermal optic cameras for troubleshooting and documentation of solar and electrical installations. I'm just going to switch off the on-screen camera. And yes, I'm Peter Prinsloo. I'm an electronic engineer. I'm going to take you through using the thermal optic cameras from HIKMICRO, as I've said, for troubleshooting and documentation of solar and electrical installations. Right, so let's have a look at what thermal optics is. And then we're going to have a look at how it works. After we've had a look at how it works, and I'm going to do a demonstration during that, I'm going to take you through some actual case studies. And then, and that's part of a example and demonstration as well. I'm going to focus on some demonstrations. And then as far as can you do it, I'm going to talk about the company and its achievements. Right, so without further ado, the visible light spectrum. I'm not going to be talking too much about technicalities such as wavelength. But the wavelength of the visible light starts at around 400 nanometers and it extends all the way up to 700 nanometers, thereabouts. So when you look at visually at some beautiful flowers, you'll see some pretty colors, and this is visible light, and it's light that's actually reflected from these objects. So what you're seeing there is sunlight, hopefully in this case, that's reflected off those flowers. Above the 700 nanometer range, we have the infrared light spectrum. Now you see another image of a flower. In this instance, it is actually heat, also known as infrared, or shall I rather say the heat manifests itself as infrared radiation. This radiation, electromagnetic radiation, is at a frequency with a wavelength that's longer than what our eyes can perceive. So what you're seeing there is an actual representation of heat that has been modified so that we can visually see that. Now, there is the electromagnetic radiation spectrum. You see in the middle there the visible light. I'm going to switch on the that's not what I want to do. Let's switch on. I'm going to switch on the laser pointer, and this is the visible light that you see over here. Above that, at a longer wavelength, is the infrared, and that extends to about 14 microns. So let's have a look at what you see. You see here, again, I spoke around 14 microns. This is infrared thermography, and this is the wavelength of frequencies that we're looking at when we are looking. Like I said, this is micrometers. So the part that we're interested in extends from around 7 micrometers all the way to around 15 micrometers. Now on the left hand side there you see a glass plate, and you can see visible light that's reflected from the person's hand. And on the right hand side you look at an infrared thermogram, and you can see that his hand actually disappears behind the light, simply because infrared, the longer wavelengths, do not transmit through ordinary glass. Now what I'm going to do is I'm going to take you to 2 demonstrations. I'm going to switch over to one of our thermal cameras. This camera that we're going to have a look at is known as the Pocket 2. I'm going to switch over to the Pocket 2. That is an image that you see of the demonstrator behind me, and I'm first of all going to demonstrate the transmittance of infrared through glass and through other objects. So, without further ado, I'm going to cover my hand with a normal black plastic bag. Now I'm going to let me switch on the lights as well, and I'm going to place my hand is now inside one of these normal black plastic bags, and as you can see, the light reflected off of the bag actually hides my hand. You cannot see my hand. Now look what happens when I switch over to a thermal image. There you see a thermal image, and you can quite clearly see my hand. You can see some areas that are more visible than others. We'll talk about that. Those are the areas where more of the heat, like you can see in my fingertips, it's closer to the plastic bag, so it transmits more heat through that you can visually see. So let's do another experiment. This time I'm going to just use a normal glass, and let me switch back to visual. There you can see the glass. This is just a normal glass, and I'm going to put my finger inside the glass, and you can quite clearly see that the light reflected from my finger is actually transmitted through the glass. You can see my finger inside the glass. However, look what happens when I switch over to a thermal image. You'll see with the thermal image, you cannot see. It's literally like my finger is disappearing on screen, and you cannot see the infrared radiation being transmitted through the glass. However, look what happens when I touch the side of the glass. You'll see that I'm touching the side, and look how the heat that's being generated on the surface of the glass actually is visible through the infrared camera. And there you can incidentally see our marker. We'll talk about this marker later on. The marker has just jumped to that to tell me that if you look at the top left hand side, that maximum is the marker. It's telling me that that's been heated up to around 29 degrees C. So that is the first principle of infrared radiation, that infrared radiation is in a different spectrum, and we make use of a system that will make that infrared radiation visible. So let's get back to our PowerPoint. Okay, so there you see what I've just demonstrated. You'll see this person has hidden himself behind a black plastic bag. The light reflected from the a white plastic bag. You'll see that the light reflected from the bag actually hides his face on the left hand side. Like I've demonstrated, you can clearly see the heat radiation from his head. Now, incidentally, this person is also wearing glasses. See how the heat behind his glasses is not visible, exactly like I've shown with the glass. The heat from his head, so to speak, is not transmitted through glass. One of the phenomena regarding infrared radiation. Right, so how does it work? This is a graphic of what it physically looks like inside. On the left hand side, you see those red infrared coming through to a front lens. Now this front lens in our case is coated with a germanium coat. Germanium is one of those elements on the periodic table. One of the properties of a germanium, when you create a germanium lens, is that it blocks out visible light, and it only allows the longer wavelengths of the infrared light to be transmitted through, or rather say to penetrate the lens. So there you see a photocathode. What actually happens is that with a photocathode, I'm not going to go into the technical details of that, but the infrared radiation hits the photocathode, and it knocks out, so to speak, electrons from the cathode. Those electrons are then accelerated towards a phosphor screen. When they hit the phosphor screen, and in our case this is actually a color screen, it becomes visible to the normal eye, as we saw with the visible light. And on the right hand side, those little green arrows are the visible image that we see from the phosphor screen. Let's have a quick look at where thermography is utilized. Predictive maintenance in electrical systems, mechanical systems, facilities, process equipment, in building inspection. We're not going to talk about water today, but because of water and the surroundings typically have a differential as far as the temperature is concerned, the infrared radiation due to the temperature difference allows us to see, for instance, water leaks. We'll talk a little bit about energy loss in the sense of what we're going to be talking about today as far as electrical systems is concerned. And then home inspection, you can see that the top two has application in home inspection, and then obviously also in commercial buildings and facilities. High voltage and air conditioning systems in a residential, in commercial and refrigeration. Obviously there's temperature differentials there which can be troubleshooted, so to speak, by thermal optic cameras. Utilities, transmission systems, anywhere where heat differentials, distribution systems, anywhere where heat differentials are common, we can make use of thermal cameras. Then solar inspection is something that we're going to be having a look at today. And then transportation systems in engines, in electrical and battery charging systems. We'll talk obviously about electrical today. And then passenger seats, things for instance like heated passenger seats, you can see what's happening there. Then as far as DIY is concerned, home inspection and outdoors and hobbies. Right, what we're going to use today is we're going to use one of the HIKMICRO cameras. This is known as the Pocket 2. I'm not going to go through all of the specifications here, but on the right hand side there you can see the Pocket 1, Pocket 2. We will be using the Pocket 2 to show you some thermal images today. That's where the Pocket 2 is positioned, right in the middle there. Now you'll see that those three products, the B series, the Pocket series and the M series, are known as field inspection and documentation. These are typically technician tools. On the right hand side you'll see three different products, the M series, the G series and the big one, the SP series. Those typically are used in full thermography inspection and reporting, but certainly the Pocket 2 that I'm going to show you today is very capable and has a lot of the features that the products, the M series, the G series and the SP series has. Then towards the left hand side, we start off with a Mini 1. That's a unit that can plug into an Android phone, and you can turn your Android phone into a thermal optic camera using that very special lens. We also have the E series and the B series. These are typically handheld devices. One of the things that is really very nice with these units is that you can handle it with a single-handedly. All right, so let's have a look. This is the M series. Just very briefly, one of the areas that's different to the Pocket 2 as far as these are concerned is that they have focus lenses, and this becomes when you're starting to troubleshoot HVAC systems, high transmission electric transmission systems like you see on the screen there, then it becomes very good to be able to focus using the focus lens. This is the SP series. The SP series is the top of the line. As you can see, it's got a separate rotating lens The lenses are replaceable. I'm going to show that in a moment. And then it's got this display that you can move at any angle. And then on the right hand side there you can see the top of the line, this SP60 series, that also has a viewfinder, and the viewfinder makes it sometimes very easy, like you see the person in the image there, using the viewfinder just to be able to zoom in to an electrical problem. These are the lenses, very useful when you need to zoom into areas like electrical transmission lines, isolators, and being able to spot differences in temperatures in transmission lines. There are the lenses. I'm not going to go through all of the lenses, but there you can see it's got a full array of different lenses, including wide angle lenses. Some application areas on the left hand side there, you see a typical what we call picture-in-picture, and there the person is zooming in on a substation, and the center there, which I'm going to show you on the Pocket 2, has the thermal image that shows you what is happening as far as that distribution system is concerned. Then as far as facilities management is concerned, there you see a piping system. This person is looking at some pipes, whatever pipes they are. But if you have, for instance, if these are pipes that are carrying different fluids, you can see the temperature difference in the pipes. And if there's any leak, you'll easily see where the temperature differential is, which is not visible through with the naked eye. You'll see the thermal image of where that's leaking. The third one from the there from the left is in manufacturing. Very often you find that bearings, when a bearing starts getting a problem, then it typically heats up, and with a thermal optic camera you can see that what is happening with that bearing. On the far right hand side you can see a kiln, and the SP series is particularly suited to that because in this particular series we have a high temperature capable device as well. There you can see the SP series, it can measure up to 2200 degrees C, and you can see a factory there with a kiln and the person zooming in on the kiln using the SP series. Let's have a look at some of the key features. We've got multiple span levels, and I'm going to show you those span levels. There's 7 color palettes. I'll be showing you these 7 color palettes and what they're used for. And then there's 4 image modes. You've got the full on thermal mode. You've got the optical mode that I've already shown you, which shows there's actually 2 lenses on the Pocket 2. One is a pure optical, the other one of course a thermal. And then third one from the left is the picture-in-picture mode. I'm going to show you picture-in-picture mode, and then there's a mode called fusion, where we actually combine the visual lens, the normal optical lens, and the thermal lens, and we can blend in a certain amount of the thermal image onto the normal optical image. I spoke about the tap level. I'm going to show you the tap level. That is a function where we can override the automatic temperature selection so that we can zoom into a particular area. There you can see tapping on that area, and then it locks the thermal image around the area of interest so that you can zoom in and more clearly see what's happening as far as thermal differentials are concerned in that area. So very high quality image. The Pocket 2 that we will be showing you as a 256 by 192 detector, is more sensitive than 40 millikelvin, which I can tell you is top of the line as far as thermal capabilities are concerned. Then very important is that the the frequency of update is very fast. It's 25 hertz, which means that it's motion picture quality. That is very important when you're doing a video, that you don't get that staccato movement that you get from a device that would be updating the image at a lower rate than 25 hertz. Then on camera's recording, there's 16 gigabyte of storage on this particular camera, the Pocket 2. So what do these key features help with? There's much faster troubleshooting. There's a built-in flashlight and a buzzer. The buzzer is something that we can set up if a particular temperature is larger than a preset temperature. The buzzer will alert you to the fact that it is measuring a higher temperature than your preset temperature. It's a pocket-sized device, so as far as the Pocket 2 is concerned, very nice to carry around, easy to put inside your tool bag to carry around, and then it's very rugged. It will survive a 2-meter drop without any damage to the camera itself. Very special is the communication mode, and what you saw earlier was my mobile phone connected via Wi-Fi to the thermal camera, and I'm going to show you later on what the capabilities of the Wi-Fi is as far as connecting to the rest of the system. In fact, right now I've created a hotspot on the thermal camera, and all of my computers here are connected to the hotspot on the camera. I'm going to switch over to the camera so you can see a little bit of what we're talking about. Over here is my mobile phone. Behind me here is another computer. We'll be talking about what we're seeing on that computer in a moment. And then behind me over here, this is the Pocket 2, and this is the demonstrator that I'm going to be using just now to demonstrate the thermal optics to you. Right, so without further ado, let's get cracking. Very nice screen on there, 3.5-inch LCD touchscreen. Then one of the key features that we also have on the Pocket 2 is what is known as a macro lens. Now at the top left-hand image there, you see using the micro lens, you can really zoom into an electronic component like you see over there. On the bottom left-hand side, you can see without the lens, you really typically have a challenge in focusing in on that component. So using the macro lens, and on the right hand side you see a stand. In this instance we're using just a normal tripod, and my Pocket 2 that's sitting behind me here is also attached to a tripod so that I can more easily manipulate it when we're looking at the demonstrator. So right, some quick comments about what you're seeing on screen, particularly in this case with the Pocket 2. Starting at the top left, that's the hotspot marker. You'll see that the hotspot marker is shown in the max temperature. Left top, you see max. That's what we're seeing as far as the hotspot is concerned. The center spot, if we go just to the right of that, the center spot allows me to aim the center of the screen at a particular area of interest to measure that temperature. You'll see the central temperature is 41 degrees if you look at the top left hand of the screen. And then there's a cold spot. Also you can see the minimum there of 22 degrees. The cold spot will find the coldest spot on the image that you're looking at. Then working clockwise, there's just the brand logo and the menu button at the top, at the bottom at least. Then the emissivity of the device. Different materials have different emissivities. I'm not going to go into the technical detail of that. We incidentally have a very good learning system, that e-learning that's online, that you can go through. It's free, and it'll tell you all about emissivity. Just very briefly, metals, for instance, has low emissivity. Typically, temperature conducts along a metal object and doesn't radiate it, whereas something like plastic, for instance, and we'll see some of that when we look at the demonstrator behind us here. Plastics typically has a high emissivity, which means that it radiates a lot of the thermal properties in the form of infrared light towards the camera, and we're going to see that. In the middle you see the temperature unit. We are of course measuring in degrees C here. We've got the time, and then at the left hand side you'll see the span level, and that shows the span that we're looking at. We're looking at a max of 54 degrees C, that's the hotspot marker, and the lowest temperature of 22.9. So that's as far as the screen is concerned. We have a menu, the top level menu. I'm going to show you that, and there's various things that we can switch on, which I'm going to show you on screen. I'm going to show you the digital zoom. I'm not going to go through the explanation there because I'm actually going to show you that. Then we can set up a thermography rule, and I'm going to show you how we do that by switching on the hot and cold. In fact, at the left hand side you see what the automatic setup has been. It's found the hottest part. So the thermography rule in this case is my hottest part is 53. I've got 20 degrees, and that we can change using the manual setup, which I'm going to show you. The span level and the tap mode, I'm going to show you that, and the zoom mode, I'll actually be showing you that. Then as far as the palettes are concerned, you can set up different palettes. Also, I'm going to show you that. Then I'm going to show you how you capture a picture, and we can capture videos as well. I'll be showing you that too. Right, as far as the accessories are concerned, I already mentioned that there's a desk mount bracket. This is a very nice bracket which just clamps onto the desk. It makes use of the tripod connector, and you can actually, as you see on the right hand image, you can move using the macro lens. You can move it to right above the, in this case, printed circuit board, so you can zoom in onto a component that may be heating up. Right, so let's have a look at our demonstrator. First of all, we've got a monocrystalline solar panel, small little panel that I'm going to show you. What we're going to have a look at is on this side, we've got just an Arduino prototype board, just with some circuitry on there. That's obviously got a little CPU, a central processing unit on there. And then that is going to be powered from the solar panel on the left hand side. This, incidentally, this is just a spark fun. And it's got a little temperature sensor on there, a TMP 36, and we'll just be using that as a object to have a look at as far as thermal is concerned. On the other side of the room here, I've got two 200 watt halogen lamps, and these halogen lamps I'm going to switch on like I've just done, and that's going to obviously generate current. The solar panel is going to convert the light that's hitting it into a current. We're going to put it through a little connector block just so we can zoom in on that, and then I'm going to measure the voltage across the line. I'm also going to then measure the current, and we will have a look and see how much current we're drawing, and that's, as the demonstrator is concerned, we'll have a look at how the system performs. So without further ado, I'm going to now switch over to the camera, and we'll be going through the demonstrator. Right, I'm going to move the glass away that we had previously, and let's first go to the visual image. I'm going to show you the visual image. So this is now those different 4 different modes that I've shown you. There's the visual image. You can have the blending mode, that's blending. So you'll see I can, in this case, I can decide to blend 25% of thermal, 50% or 75%. Going back, I can go to the picture-in-picture mode that I've mentioned, and there you can already see that it's picking up the processor, that little processor in the middle of the board there, the red marker you can see is running at around 30 degrees. The center of the screen, which is, as you can see, is pointed at somewhere on the printed circuit board, is around 27 degrees. And then the cold part is probably in the back of the room there, where we've got a minimum of 23, which is probably the ambient temperature in the room over here. Right, so over there you see some 2 multimeters. I'm just going to switch them back on. So let's just get our voltage. So you can see that there's around 5 volts being generated across the from the solar panel. And let's zoom into the solar panel. There you can see the little solar panel that I'm using, and there you can see in picture-in-picture mode it is it's fusing some of the visible light. If I now switch over to full-on thermal, you'll see that I'm seeing some reflection coming off of the panel from the lights, and that's a very important point that we're going to discuss as far as troubleshooting solar panels are concerned, because that is not the temperature that is part of the panel, so to speak. One needs to get into a proper angle to stop that infrared radiation that is actually reflected from the panel. A very important point when you're troubleshooting a panel. What I'm going to do is I've got a little gas heater lighter over here. I'm going to show it to you in a moment. If I click the button, you'll see that generates some heat. And what I'm going to do without damaging my panel, I'm just going to heat up part of the panel so you can see what it looks like when part of the panel is heated up. You can see that my marker has immediately jumped to that part, and it's measuring around 44 degrees where I've just heated up the panel. Okay, so let's have a look at the rest of the circuit, using first of all some of the capabilities of the thermal optic camera. The palette that you're looking at the moment is known as rainbow. So starting at the top, I can go to something that's known as black hot. That is known as white hot. Then that is what is known as ironbow. That is rainbow. And that is known as rain. We've got fusion, which fuses some of the optics and the thermal. And then we've got the red hot. So those are the different palettes. I just want to get back to fusion mode to show you something. I'm just going to choose, I actually quite like the rainbow palette, because that gives me like a nice spectrum of visible light, starting at the blues and the dark ones. Now, look on the left-hand side of the screen. There you'll see my thermography extent. It's the process is running at around 30 degrees right at the top. You can see the red marker. And then right at the bottom, as part of the room here, there is it's 24 odd degrees. You can see the cold marker jumping up and down there. Right, so I'm going to have a look at the panel again. Now the zoom function, I'm going to show you the zoom function. I'm going to zoom in on the panel. Here's the zoom function, zooming in on the panel. Now as you can see there, I cannot see the individual cells of the panel. Now what I can do is I can go into what is known as fusion mode, and with fusion mode it will give me the visible outlines of an image, and there you can quite clearly see the cells within my little panel over here. Very, very useful when you're trying to determine that there is a disconnect between cells and which cells it is that's disconnected. Right, so let's zoom into some other feature. There you can see incidentally the fusion mode is bringing up the actual light from my 2 meters there. If I switch over to pure thermal, you can't see them because obviously that's in the visible spectrum. I'm going to now zoom in on a little device here. That's a little diode, and that's just showing you how sensitive this is. Let me switch on to the visual. Now I'm going to show you something as far as the visual is concerned. You'll see that my marker is slightly offset at the moment. That is just a parallax error that I can correct. I'm showing you that so that you see that there is a slight difference between the two lenses. There's two lenses like I mentioned. There's a thermal lens and there's a normal optic lens as well. Point being that we can set up the parallax error, and the parallax error is easily corrected. Now what I'm going to show you now is and I'm actually going to do that at the hand of my little demonstrator that I did before. I'm going to place the glass in the image, and I'm going to switch over to thermal mode like we did before. Now you'll see, let me zoom out somewhat so we can see more of the picture. Now you'll see that when I bring my hand into the picture, see how the automatic correction, how the automatic actually changes the picture. Now let's say I want to rather zoom in on that area where my finger is. I can go to the mode where I can select an area. See how it's automatically set up a rule there. I can now do my little experiment, and when I take my my hand away, my thermal range stays the same. And let me just show you what my automatic system will do. If I were in automatic, it would do something like that, and it actually stops me from an assessment of a particular area under test. So that's just the span level setting and the ability to go to manual mode. I'll show you that again. There I am. I can set up the mode. That's I'm setting up that. Now look again, what happens is I'm heating up the side. I take it away and I now stay within a certain thermal range. Right, I'm going to go back to automatic, and then let's return to the rest of our presentation. Right, just showing you again what we're talking about. I'm going to switch to the camera right behind me. I've got another computer, and I'm now going to show you the analyzer and what we can do with the analyzer. Now this is software that's available free of charge, so to speak. It's a license free that you can download free of charge for use with your thermal optic camera. So let's switch over to that. We're now looking at that computer behind me here, and you'll see that there's a thermal image that I've captured before. What I'm going to do is I'm going to switch to some images that I've captured before, and over there let's have a look, and I'm going to switch on what is known as analyzer, and you'll see my little panel behind me here, an image that I captured before. Now I'm going to show you that when I've actually captured something on the camera and I'm taking it back to the office, so to speak, because the camera image contains all of the information that was captured, I can post taking the photograph, go back to the image, and let's say for instance I'm back in the office and now I see, yes, I've measured this high temperature, but hang on a second, there's something that I need to have a look at here. What was the temperature here? It's something that I may have missed, and like you see, I can move it to that particular spot, and I can measure the temperature there. On the top right hand side, you can see a visual image. When I switch on, when I take a photograph, it actually captures the visual image as well. Now you may know that sometimes you actually get to like a distribution board, you take a thermal image, and I can tell you that happens a lot, and then looking back at the picture like the one on the left, you're not sure exactly what the orientation was, where was this particular, and then the visual image, in this case this was a picture I took some time ago, and I can see the surroundings visually and get a good indication of what it is that I'm looking at. At the bottom here you'll see the different wavelengths. I'm not going to go into that, but the point about that is that it captures a lot of what the extent was of the thermal image itself. So let me switch back to my captured images, maybe look at something else. I'm going to look at that one, and let's analyze that. There you see a picture in picture mode that I took, and like I said before, I can go and have a look at, in this instance, look at, there was a reflection off of my analog meter over here that was at 40 degrees, and the processor here was sitting at around 37 degrees. Again, there you can see the visual image. Now something that is let's look at something else. Let's just see what else is over here. That's the panel. You can see that I've captured a number of images over here. Let's look at this. Let's have a look at this one, and let's say that I want to generate a report. There are various facilities using the analyzer. The two that I'm going to highlight today is like I've just shown, the post image capture capability, and then the ability to generate a report. Now there's various templates that you can also set up. I'm just going to use the default template to show you, and then it generates a PDF document. There you can see I can fill in the client, the address, the date, the person that was doing it. This is the overview page. I can put some comments in here. I can post some other pictures in here. And then if I look at the actual, this is, like I say, the default template. I can see the actual thermal image and the normal visual image over there. And there's some notes that I've made here. You know, there's something wrong, repair immediately. There was a baseline that I set up. So there's various things that you can do as far as the report is concerned. This is automatic. It looks at the maximum temperature. It looks at the the image minimum temperature. It looks at the distance that I've got set up, and incidentally that's something that I can do on the camera itself, is I can set up the distance because as far as thermography is concerned, of course the infrared radiation, the intensity of the infrared radiation coming towards the camera dissipates with distance. So it's important that you also know what the distance is so that you can calibrate it as far as the temperature is concerned. And then at the end of it, there's an appendix where you can add some more photographs, etc., etc. Very, very nice feature. Now this feature I'm going to show you in a moment is also available straight off the phone that's connected via the hotspot to the unit. So let's just quickly switch back to the phone. This of course is the phone showing the image of what we are seeing on the thermal camera. Right, so I'm just going to change the orientation so we can have a look at the facilities, and let me change the orientation here as well. Right, so we're looking at the camera, and let's switch this off. We're looking at the camera image on the phone. Now just something that I want to show you here. I can change image modes right from the phone itself. There I can, for instance, go into blending, and using the blending, I've now got a slider where I can slide in the amount of thermal that I'm looking at. As you can see, I'm switching in more and more thermal, moving the slider. I can switch to picture-in-picture mode. Now I'm just going to show you something whilst we are in picture-in-picture mode. I'm going to use a high-intensity torch, and I'm going to light up the area behind the scene. Now you can quite easily see the light reflected by the torch that I'm shining on the image. But look at the minimal, because of the fusion capabilities, you do see some movement in the picture-in-picture mode. But let me switch to full-on thermal. Right, I can promise you I am now doing the same that I did before, shining the torch on the object behind me, and as you can see, just proving the point that infrared is that part of the spectrum that's not visible to the eye, and we're seeing that there at the moment. Okay, so let's moving on. Let's have a look at what I can do with I can go into the albums. There you can see various pictures that I've captured. I can look either at pictures or at videos. There's some videos that I've captured. I can run through the video that I've captured. That is, for instance, yeah, there wasn't much movement on that one. Let's have a look at another one, see if there's more movement on it. There you can see the meter moving. And yeah, there I'm moving it around, so you can see. Yeah, that's the creaking from our dear tripod over there. Right, so what I can also do is I can go to the on-screen device. I can select a particular image, and once I've selected an image, I can download that particular image that has been captured. But not only that, I can also go into the album, go into a particular image, and as you can see at the bottom here, there's a report. I can click on the report. I can say this report is report number 2, and when I hit next, it actually generates a report for me that I can download, and there is my report. I can be in the field and I can send that report to the office. Right, so that is as far as the, let's just switch back to my presentation. Right, looking at the presentation, we've already seen that, let's just go there. Let's say there's on the right hand side, you see the hotspot created. Let's say there's something happening on the panel between the cells that shows up as a heat image. If there's a connector problem, that shows up as a heat image. Any connection along there, you'll see a heat image coming off, and if there's another component on the board, it'll show up as a heat image. Right, so we've actually gone through a lot of the examples at the moment. Here are some solar panels that we've taken a picture of. The image on the right hand side, you can see some snow on the roof there, and that is represented as very cold. You'll see some image off of the panels, and that is where it is very important to know at what angle you're looking at, so that you're not looking at the reflection of infrared radiation, but that you're looking at radiation that's actually coming off the panel. Electric utilities, hot pushing, that's simply where on an isolator there's a poor connection on an isolator and it starts heating up. Hot breakers, you know the story about hot breakers in a distribution panel. There you see the third image from the left. You see the solar panel inspection, insulators, at the bottom left, connector issues, isolator switches, transformer temperatures. Obviously, if a transformer starts heating up, you can pick up that there's a problem. Surge arresters, if there's part of the connectors heating up. Right, this is my own little distribution panel in my solar system. The thermal image on the left. There you can see the DC surge arresters heating up somewhat. There's obviously some DC current going through there, and there's a picture-in-picture mode on the right hand side. This is what my panels look like, the visual image on the left there, and then the thermal image on the right hand side there. There you can quite clearly see that there's some reflection off of the building behind me, and that is what you don't want. For me to do a proper inspection of my panels, I'd probably get on to the other side of the roof there, and then get at a point where I do not get the infrared reflection from the building like you're seeing over there. Okay, so as far as the included software is concerned, I've already shown you the viewer. That was the one that we saw on the mobile phone. There you can see the different images, the capabilities that I've actually shown you. There's just more about it. I've actually shown you that reporting capability already. Then the analyzer was the software that we looked at previously. We can analyze it on the computer, and I've shown you how we can export a report. And again, this is free software that you get when you buy a thermal camera from HIKMICRO. Okay, so let's have a look at the company. Can you do it? Who are we? What do we do? We have more than 1,300 employees in the company. Just a shade under 400 of those are masters and PhD engineers, and the company at this point in time already has 115 patents registered to the company. The mission is our mission is to put a thermal camera within reach of every person to be able to make use of the thermal imaging capabilities like I've just shown you. Right, so the company itself, the manufacturing facilities, it's a 10,000 square meter manufacturing facility. They manufacture, or we manufacture, more than 1.5 million cameras annually last year. There's a lot of products already in stock, so stock situation is well under control. The factory itself is fully automated, so the core components is actually supplied and manufactured by the company itself. So we're not dependent on any other company for the core components that we use inside the unit. Then the company is ISO 9001 certified, and the products meet the FCC Federal Communications Commission's Class B and the EU standards. We also have the full anti-electromagnetic level 3 certification. And then as far as the anti-static interference is concerned, we meet both the 8 kilovolt contact or the 15 kilowatt air electrostatic discharge test. As far as calibration services are concerned, yes, we do have calibration services in South Africa where we can calibrate your device. And that's it from me. I thank you for attending this webinar and look forward to hearing from you as far as the use of thermal optic cameras are concerned.